Lagrange's interpolation formula. Lagrange's interpolation formula is used to find the values of a function where the arguments are not at equal intervals. That is, the arguments are non-equidistant. Consider a function y equal to f of x, which takes the values y0, y1, y2, etc. till yn for the non-equidistant values x0, x1, x2, etc. till xn. So Lagrange interpolation formula is used to find the value of y where the arguments x0, x1, x2, etc. till xn are not at equal intervals. They are non-equidistant. Then the Lagrange's interpolation formula is defined as phi of x is equal to x minus x1 into x minus x2 etc. till x minus xn, the whole divided by x0 minus x1, x0 minus x2 etc. x0 minus xn into y0 plus etc. So this is the first term. Now take a close look at the first term. You can see that in the numerator we have many terms, right? Look at each term. Look at the pattern that is followed. In the first term we can see that the first term x minus x1 into x minus x2 etc. till x minus xn. That is, in the numerator the arguments from x1 till xn are subtracted from x, right? In the numerator the arguments x1, x2 etc. till xn are subtracted from x. That means x0 is excluded in the numerator, in the first term of the numerator. Okay. Now look at the denominator. Here what we have written in numerator is taken in the denominator with the change that x is replaced by x0. Okay, so in Lagrange's interpolation formula, in the first term we can see that in the numerator all the arguments except x0 are subtracted from x, and in the denominator that the entire term in the entire term x is replaced by x0 and written as such. Then y0 is multiplied to the first term. Now look at the second term. In the second term you can see that in the numerator we have x minus x0. In the first term we did not have x minus x0. It started with x minus x1. Here in the second term x minus x0 is there, but x minus x1 is not there. After x0 x2 is taken, right? So that means in the second term x minus x1 is avoided and all the other terms are included. Okay, and in the denominator that x is replaced by x1 and the rest is written as such and multiplied by y1. That means in the first term x minus x0 is avoided. In the second term x minus x1 is avoided. So the third term, what will happen? The third term will be x minus x0 into x minus x1, and we avoid x minus x2 in the third term into x minus xn etc. till x minus xn, and the denominator becomes, instead of x1 in the third term, x2 minus x0 and so on. And the y term will be, instead of y1 it will be y2. Likewise the nth term, in the nth term what will be avoided? X minus xn will be avoided. All other terms will be there, and in the denominator x will be replaced by xn and multiplied by yn. So this is the pattern for Lagrange's interpolation formula. Now the y0, y1, y2 etc. till yn, these these are the coefficients. These coefficients are called Lagrange's interpolation coefficient. So in this equation, y0, y1, y2, etc. till yn are considered as the coefficients, and these coefficient values are called Lagrange's interpolation coefficient. And there is a an inverse form of this interpolation formula. That is, in the original Lagrange's interpolation formula, we are actually finding the value of y when an x is given, right? When an x is given, we are actually finding the value of y. So it can be used in an inverse form where we know the value of x and we have to find y. So look at the change in the formula. Here phi of x is replaced by x. That is, phi of x means y. So y is replaced by x, and wherever x comes, it is replaced by y. Look, x minus x1 becomes y minus y1, x minus x2 becomes y minus y2, etc. till y minus yn. Denominator the same thing, where y is replaced by y0. Then instead of y0, here we use x0. Like that, the rest of the terms can be written. So this is the inverse interpolation formula, where you can find the value of x when we know the value of y for a given value of y. So this is Lagrange's interpolation formula. So Lagrange's interpolation formula is used when the arguments are not at equal intervals. For unequal intervals, we use Lagrange's interpolation formula to interpolate a value. Now let's find the value of f of 4 for the given data using Lagrange's interpolation formula. So using Lagrange's interpolation formula, find f of 4 given that f of 0 equal to 2, f of 1 equal to 3, f of 2 equal to 12, and f of 15 equal to 3587. Now we know that Lagrange's interpolation formula is used when for unequal intervals. So we can check that whether the given arguments are at unequal intervals. Here the argument values are 0, 1, 2 and 15. So 0, 1, 2 and 15. That is, the x values are 0, 1, 2 and 15. Now look at each consecutive values. 0 and 1, the difference is 1. 1 and 2 also, the difference is 1. But in the case of 2 and 15, the difference is 13. That means they are at unequal intervals. Okay, so x is at unequal intervals. That means we can use Lagrange's interpolation here. Now the y values, that is y equal to f of x, the y values are written below the x values, and I have made a table here for x and y. Now what we have to find is f of 4. That means we have to find the value of y when x is equal to 4. Now let's write the Lagrange's interpolation formula here. We know that the Lagrange's interpolation formula, phi of x is equal to x minus x1, x minus x2, etc. till x minus xn divided by x0 minus x1, x0 minus x2, etc. till x0 minus xn into y0 plus etc. Now here in Lagrange's interpolation formula, we don't need to construct any table. We can use the values, the data given directly. We can substitute the data given directly into the formula. So we know that since we have to find the value of f of 4, that means x is equal to 4. In this formula here, x is equal to 4. Since we have to find f of 4, that means for the value of x is 4. So substitute 4 for x in the Lagrange's interpolation formula. Now the rest of the terms, that is x0, x1, etc. till xn. Here we have 4 arguments. That means the first one is x0, this is x1, this is x2 and this is x3. The corresponding y values are y0, y1, y2 and y3. Right. Now we can substitute these values in the formula. So the first term is x minus x1. That means here x is 4. So 4 minus x1 is 1. 4 minus 1. Then the next term is x minus x2. That is 4 minus x2 is 2. Then the next term will be x minus x3. That is 4 minus x3 is 15. We have only till x3. So we can stop here. The denominator is, instead of 4 we have to replace this 4 by x0. The value of x0 is 0. So 0 instead of 4, 0, right? So 0 minus 1 into 0 minus 2 into 0 minus 15 into y0. The value of y0 is 2. So into 2 plus the next term. In the next term we know that the second argument will be avoided. That means 4 minus 0 is there, then 4 minus 2, 4 minus 1 is avoided, then 4 minus 15 divided by the same thing where 4 is replaced by the value of x1. That is, in the second term x1 will replace x. So 1 minus 0, 1 minus 2, 1 minus 15 into 3. The next term, the third term is here x2 will be avoided. That means 4 minus 0, 4 minus 1, 4 minus 2 will not be here, then 4 minus 15. The denominator, instead of 4, 2. So 2 minus 0, 2 minus 1, 2 minus 15 into the next y term, that is y2, 12. And the last one is 4 minus 0 into 4 minus 1 into 4 minus 2. Here the last x3 will be avoided. So 4 minus 15 will not be there. Instead, in the denominator, 15 minus, we replace 4 by 15. So 15 minus 0, 15 minus 1, 15 minus 2 into y3. Now this is how we get after substituting the values in the given equation. Okay. Then after simplifying this equation, we'll get the final answer. So after simplification, we'll get the answer as 78. That is, f of 4 is equal to 78.